Alright guys, in this demo we're going to talk about the material domains. Now, material domains are different than what we just finished talking about, of course. In the previous video, we talked, let me go ahead and open this material here. In the previous video, we talked about the blending modes. As you can see, let me hide myself here. Sorry, camera. In the previous video, we talked about blending modes and how each of those blending modes affect the way that the background is being parsed through the material. Let's talk about material domains. This is how the material is being kind of seen by the engine as a whole. And this changes functionality. The other one changes functionality of the background. The material domain changes the functionality of the material. So let's go ahead and start as simple as possible. You guys remember this from the last demo, or the last showcase here when we were showcasing the blending modes. I'm going to go ahead and open this up and we're going to have a look. I just picked that one at random. This is supposed to showcase the material domain for surface. This is a standard surface with standard problems. It is typically what's going to contain the majority of your options. This particular standard surface is just the ability to describe a 3D surface. That's it. 99% of your objects will be surfaces. Anything that you can see in the game is typically a surface. And then the blending mode will control whether or not it's translucent or not. That's typically going to be what these are for me. In this particular demo, it's masked, but very rarely will you use additive and modulate. But typically speaking, your material is going to be a surface domain with one of these three options, typically opaque. Let's move on. The next material domain is probably the one that everyone appreciates the most. I have some blood for you guys here. I've got some different types. I have one from Megascans, and I have one that I've made a little bit more bright, one that is visible in the darkness. But they both have the same kind of processes. What this is here is what's called a deferred decal. If we actually go into our place panel and type in the word decal, that's what that is. Dragging in a decal brings in a volume. That volume can then be scaled as needed, and in the details panel we can see that the decal can have a material. I'm going to move this over here so you guys can still see that the default material is available. But these decals have already been populated. As you can see, this decal is just a square that has a material applied to it. Let's go ahead and check out that material. This material domain is set to what's called deferred decal. This is the material domain that, as you can see, changes a litany of options. Ignore how this is built. This is just built to kind of showcase this element. I will show how to make these shortly. This doesn't have anything in it. Whoops. Sorry about that. As you can see, a deferred decal can have a different blending mode as well. And these blending modes can change based on what you want this element to be. In this particular case, this is treated as either translucent, a stain, normal, meaning that the normal map gets blended in, that lovely purple, or an emissive. Typically speaking, you will either want to have a stain or an emissive, depending on what the material is doing. Emissive if it's glowing, a stain if it's just supposed to look the way that this is supposed to look right now. Stains are typically used for decals. This is where you save a lot of like dirt and nasty mucky textures so that you can create a bunch of these particular materials to put them on a surface. As you can see, there's nothing special about this. This is literally just a blood texture, like I showed you guys earlier, that is applied to this material as a deferred decal. It's the second option. And the previous rules apply. In this particular case, I'm using the translucency because it is see-through. I am, however, in this particular case, using some tricks to make this, let me go ahead and put that stomp out, to stomp that out in a way that looks almost like an opacity mask. But since opacity masks are expensive, and you can see that I tested this out initially with an opacity mask. What I did here was I just used this particular process to make a cutout for my opacity. Now this does still work similarly to how an opacity mask works without actually having to apply an opacity mask. I wouldn't worry too much about how this is made. Typically speaking, if you were going to do something like this, it would probably be better off as a mask. But in this particular case, this texture was made in such a way that it's actually fairly easy to grab the alpha information from it, which is in this particular channel. This is getting to more like advanced esoteric abilities to make textures. And then those are piped into the texture itself. And the texture is uh-oh, did I freeze? Come on. Sorry about that, guys. Small freeze there. You can see that this texture is entirely transparent. So I don't actually have a full-on mask. It is 100% transparent the same way all the way through. And then that is applied to the surface as a stain. The shading model is currently set to default lit. We don't have to worry about the shading models just yet. This is going to be another conversation. But the shading models will control the essentially what their refined use is going to be. This is where you can get things that are unlit, things that have skin, things that are clear coat, which means they have a surface on top of them, so on and so forth. But I'm not going to get too far into shading model for now. We don't have to worry about that. We just have to worry about the material domain. This is a deferred decal. A deferred decal is then applied to a decal actor, and that decal actor can be moved around. See how that works? And I have two, just for an example. And also their presence can change based on where that box is, if that makes sense. Decals are pretty powerful. They're also a pain in the butt to make, and also a pain to kind of make them work well. I grabbed these from the Megascan store. This one I custom made using the Megascan's textures, and this one is, let's see if I can grab it. I moved it a little too deep. This one is the Megascan itself. I'll talk about master materials here shortly. And this is their material. As you can see, mine isn't based on theirs. Mine is based more on a simpler kind of build out. But anyways, we don't have to talk about that too much. We just have to showcase that that is a semi-translucent material that is a deferred decal. This is a decal actor, and decal actors have their own custom textures applied to them, which is called a decal material. And this is again showcasing material domain. I would say about maybe 5 to 10% of your textures will be these, because they're just really nice to be able to build out a bloody scene without actually having to texture this. Imagine if we just had this and it was covered in blood. Well, what happened if we had a state where it wasn't covered in blood? Well, we would have to make two textures. But now we can actually make a texture that adheres to the result there, and now we have bloody cotton. And then we can very easily take that away, put it back, rotate it, so on and so forth. The next material domain is a light function. I'm going to open up this material. In this particular case, this is just a spotlight. You guys have seen the spotlight before. It's not doing anything crazy or weird. I've set it to movable, and it's not doing anything other than what it's doing essentially out of the box. It is using color temperature. It is affecting the world and casting shadows. You guys should have at least a minimal grasp on how all this works. However, if you scroll down, and I mentioned this in a previous demo, you have access to a thing called light function. A light function can take a material. That's what the little green line is for. This material domain is now from surface to deferred decal to light function. As you can see, a light function only has one option. Ignore the math. This is just how it works. This is just how this is moving. There's rotators, there's panners, they're moving. All of these and how they're rotating and panning can be seen through the preview node. For example, this particular node has a very, very slow rotator. Don't stare at that too long, it will actually trip you out. So seriously, do not stare at that too long. I'm going to turn that off. So all of this material is just the same material treated slightly differently and moving. That's all it is. But because it is set as a, and by the way, each of these options have their own details panels, you can see very clearly. Clicking on the background will change it back to the materials, or clicking on this will change it back to the materials default functions. This is just a light function. It turns off the other elements. This is very, very cheap and is typically used to do things like, I don't know, you can make stained glass colors on the ground, you can emit certain lights, you can project certain functions. This is where you can create flashlights, this is where you can create cookies. A light function essentially modifies what a light is supposed to do. That's it. They're very useful for these elements right here. Let me hit G to turn that off. See? Fairly basic, fairly straightforward. We have our blood, deferred decal, and then we have our regular material domain, our default one. Again, before we look at the last one, let's recap. This is a surface domain. Most of your objects will be based in surface, and in fact, you almost don't need to worry. At least in my class, you don't have to worry. This is a deferred decal with special settings to get it to work. And this is a light function. Surface, deferred decal, light function. About post-processing, because this is how you make like active film grain and stuff like that. But essentially you can make a texture that animates to create kind of like a film process or like a gel over the camera. That's what you would use that for. User interface essentially is if you're using this for the UI or UX. If you have a special texture that's going to be going on screen for the character to see, it's better if it's used as a user interface. We'll talk about these two later, more so this one in the future. Let's look at the last one here. This is just the post-process volume. You guys should already know how to make a post-process volume. In this particular example, infinite extents is set to not unbound, meaning the extents are bound to that particular area. Let's go ahead and I'm going to go ahead and click on my modified properties. And as you guys can see, I have a post-process material in here. Let me go ahead and turn off that process here. And let's see if I can find it. I always have to find it from here. There we go. Let me go ahead and bump this open and smooth this out. We can see that we do have a material in here. Let's go ahead and find that. Again, we are clicked on the post-process volume, and the post-process volume under rendering features can take a texture. What does that mean? This is the final material domain process that we're going to look at. This is a post-process. I actually did set that up. I forgot about that. We don't have to worry about volume for now. This is basically how the material attributes will describe a 3D volume. This is mostly for like smoke. This is effects. We can't really do too much with that. Again, very similar to the last discussion. These three here are going to be the ones that you typically use. Volume for, say, in events that you need to control an actual volume, not sound volume, but a 3D volume like smoke or water, especially if it has some impact on how that volume is supposed to work. And user interface is still the same. I guess let's talk about post-process then. Post-process is something that you can apply to the post-process volume. Let's take a look very quickly at what this is actually doing. Very similar to our light function, we only have access to emissive color. However, we have the ability to apply this texture because it's set up as a post-process material, can be used in a post-process pass. Let's go ahead and go back and let's have a look. Let's go inside. Does everybody see kind of what's happening with film grain? These are kind of a pain to make, as you can see. Not lying about that. These are kind of a pain in the butt to make, especially if you're going to be using kind of like a global effect. But as you can see here, it is pretty straightforward. It's just a texture. It's just this texture. But each of these little things can be moved. As you can see, there's some tricks to kind of move the different orbs, for example. We're only getting the B channel out of this, which means only the line is going to move. Let's preview that. That's what the texture is doing, by the way. That's what the panner and that's what all this time function is supposed to do. It's just moving the texture like crazy. That's it. And then the other elements are supposed to be kind of the other elements are supposed to be the film grain. Let's preview that node. That's it. And the final result, we stop previewing node. Sometimes it doesn't update right away. Sorry about that, folks. Had a weird freeze and then nothing would update, so I ended up closing the engine and starting it again. It seems that we have everything back. Something that you guys will get used to is if you not even accidentally, but if you preview node, for example, this should be showing us that, and then stopping preview node should give us back our value, but sometimes this can break. This is probably a bug in UE5. This is not actually showing us our actual output. Let's do our preview state. Let's see if we can actually force it here. So if you end up previewing a node and it doesn't actually stop previewing a node, just close it. And instead of having to restart the entire engine, just open it again. I don't know what this bug entails, but that's definitely a bug. So if you're looking at certain preview nodes and it's doing that, you guys probably won't be previewing nodes, but that gives you an idea of why it would be doing something like that. I don't know why this doesn't intentionally like to give us our preview back, but I think it's a bug in UE5 with how the shader is supposed to bump over. It is what it is. Anyways, post-process, we still have access to our default shading models, but these are supposed to be refinements to what the texture and or what the shader is supposed to do. Sorry, I keep calling them textures. And as you can see in the game world, if you pay attention very closely, you can see that the texture is panning, and these are textures, but the shader is affecting the screen because we are inside the post-process volume. Alright guys, that's going to do it for the discussion on material domains. These are not things that you need to horrifically worry about for now, but they are still good to kind of understand and know. so that you guys have an opportunity to kind of put this together for yourselves and kind of start building some stuff up. Let's go ahead and now move on to the next step. I'm going to give you guys a texture. Now you guys should have access to this texture in the modules, and if you don't, go ahead and download it right now. It is just a collection of textures. What we're going to be doing in the next demo is we're going to be connecting some of these materials, and we're going to start using more or less using the game engine to start expressing these materials in such a way that would work in a particular game. We'll cover tiling, we'll cover all of the different ways that you can expose a material to height and more detail. We'll talk about how Unreal 5 changes some of this stuff, and then we'll go from there. Alright? So in the next video, make sure you download those texture packs that texture pack, that I have for you guys, and then we will get started in the next video.